So the tree line is the key. That's what we need on Mars. Because trees and forests are really going to move Mars from just a warm carbon dioxide-rich planet to a planet with oxygen that's breathable by animals. Forests will be the engines that create the oxygen. And that engine of biological productivity is what will drive Mars into a state that will be a rich and diverse biosphere.
Research at Orizaba finds that 41 degrees is the minimum average temperature for the world's hardiest pine trees. When parts of Mars reach that threshold, the planet will be ready for trees of its own. It will begin with high-altitude pine trees imported from Earth. They can handle low oxygen and high radiation and spread their seeds on the wind without help from animal pollinators.
So we go from bare, volcanic rock to a forest full of life. In fact, the tree line on Mars will look like the tree line here on the highest mountain in Mexico. These extreme high-altitude trees are the first organisms that might be producing significant oxygen on Mars.
It will take generations of work and possibly genetic engineering to get things started. But then the Martian forests will spread on their own, improving the soil and the atmosphere, creating a livable world for more than just plants. In the not-too-distant future, humans may have the tools to transform Mars from a cold red desert into a habitable world. But importing life and turning Mars green will raise questions that we've never faced before.
We can restore habitable conditions to Mars. The fact that we can, to me, opens up the question, should we? What we do will, I think, set the pattern that will reflect on us as a species for the rest of time. Mars will be where we set the precedent. And that's why I think it's very important that we do it carefully.
There's no sign of life on Mars today, and every reason to believe that it can't exist on the surface. The lack of water and shelter from radiation guarantee that. But there could be ancient microbes frozen in the ground, needing only warmer temperatures to wake up. If so, they could answer the biggest question in space science. Has life originated more than once in the universe? Mars and Earth have been swapping rocks for billions of years. What's knocked off one planet by an asteroid strike often lands on the other. And it's not inconceivable that microbes have sometimes gone along for the ride. So life on Earth may have come from Mars, or vice versa, which would be interesting, but tell us nothing about whether life originated anywhere else. But if Martian life turned out to be unrelated, a separate origin just one planet away in our own solar system, that would suggest that life crops up wherever the conditions are right. And a universe with billions of galaxies and trillions of stars could be teeming with life. It might also mean that life from Earth could be a threat to Martian life. So how should terraformers treat the natives, if there are any?
It would be best to try to answer that before we started warming up Mars, because what we do depends on the answer to that question. If we find that Mars has life that's the same as Earth's, then it doesn't matter, and we move down the path of sharing life from Earth with Mars. But if we find that Mars does have life, and that life is a separate, independent origin of life, then we do things completely differently, in my view.
In that case, McKay thinks we should sterilize all of our old space junk left over from previous missions. Even hundreds of years later, it could still be contaminated with bacteria from Earth. And then we should leave Mars to the Martians.
I would say our responsibility is to encourage that life to flourish and thrive. Diversity in life across planets is a good thing. And we would learn an enormous amount about how another biosphere based on that life might work. And that knowledge could revolutionize our understanding of fields like medicine and agriculture, as well as helping us understand the Earth by having a comparison biosphere.
But not everyone would go along with that approach, especially after going to the trouble of making Mars habitable.
I don't agree that that is a rational ethical position. The ethics need to be based on what is good for people, not what is good for bacteria. This idea of depriving humanity of a fully living world, not just for humans, but for a wonderful ecosystem of plants and animals and birds and fishes and all of this, in order to preserve this place for bacteria, is lunacy.
Picture the tracks left by the Mars rovers. It strikes me there's two different ways you can view that. One is the despoiling of a pristine, perfect natural landscape that should have been left alone. It's akin to tracks left by some four-wheelers who were driving on some beach and ripping up the dune grass, and it's vandalism. That's one way to look at it. The other is picture this evolutionary moment of life coming to a place with no life. To me, that's inherently good. In my view, if Mars is lifeless, it really changes the equation.
There are a lot of unknowns, and we need to understand Mars better to be more confident that something won't go crazily wrong that we're not expecting. But it's hard to have a bad consequence on a rock. The rock will be a rock, and dormant life will stay dormant unless you do something about it and make it a more habitable place.
Because we live on a planet that's so full of life, we tend to think of disturbing nature as synonymous with disturbing life. And we don't have much experience with places that are truly, truly dead. In my view, Mars is like the vacant lot next door. Why not go there and